put double A and double B. If it changed to integer, it's fine. But we also see in the public, the return type is double. So whenever we return the integer or the numeric number, we need to change it to double. So maybe we can just return and have a bracket called double A divided to B, and it can be only be one line.
Okay, so here, if I wanted to erase this, and then how can we change this? Return, erase. We want to get a result. What's the return?
We can return A divided to B, and before we can have a bracket called double. Then we can ensure the return is a double type.
No, we don't need to. We don't need to. Okay.
Just return A divides B, because if you go to the double method of this, one of this is a double, so the compiler will automatically make the calculator is a double, so it will return double. So just return A divides B.
Yeah, good. So we can condense that. Of course, if we wanted to use the variable later, all right, then we use C or whatever variable. But if you don't, only the results, then actually return this. It's okay. Remember what I said, that you have a double, that's enough. Whatever is int, you can enter the decimal. No, it's matter. Okay, that is one of that. Okay, I'm going to give you an exercise, right? So the exercise here. We have the situation, all right? Presume we have a class circle. A circle is going to do something, and this example, circle is going to calculate the area, all right? A square also has implementation, calculates square. And now we may have other class, rectangle, right? Square is different from rectangle. But no, it's quite similar but different. Rectangle, right? That is rectangle. Now we have another class, right? Calculator. So calculator said overloading, right? So overloading, we still can take the object type, right? So object type circle C, right? Then C can calculate it. A square, all right? Take square. You see that the same method. Take different object, right? As parameter. So the object variable we can calculate differently. The problem is, right? So we may have different shape, different. So I said rectangle, right? So we have a new class, right? Then the calculator, of course, no. We need to have that. We need to take rectangle, all right, and then go to rectangle to calculate that. Right. So I want you to think, how can we apply polymorphic technique? Of course, override is one kind, right? So override is inheritance, but we don't encourage use inheritance to do all the overriding, right? Even inheritance is one of the polymorphic technique. So to solve the problem, we wanted to make it maintainable, right? So we have different shape of lengths. Now the shape, we add a rectangle, right? Rectangle. So we have rectangle, we have square. Right, then we need to make it maintainable, flexible to change. So I'm going to give you a hint. They wanted to so the shape. So I hope you to create a shape, right? A shape. The shape is abstract, right? A shape. Under the shape, we have rectangle, we have square, we have circle, all right? So you got inheritance. And another calculator, right? Try to set it as the interface. Right. We have a calculator, that's the interface. And then we can calculate rectangle, calculate square, circle, right? Each calculation as a class, right? The class implements calculator like that, right? So I want you to do that and to calculate area. All right, so do it. First, you probably have a picture, right? The diagram of this question and how to write a code. So do it now. You need to go to the restroom or whatever you can go, but 15 minutes later, I'm going to ask you. 中文讲一下。这个问题这个 polymorph， 当然我说两种这种 polymorphic 的 technique， 一种是 override， 这是两个 class 的关系，我改变它，凡是我改变的，那这就是会变成不一样，就是 polymorphism 了那另外一种呢是 overloading overloading 就 method， 然后 overloading。那这些都是 polymorphism， 而这个 question 呢，它的 polymorphism， 他说用 polymorphic technique，override 它是一种方法，当然是吧，但是呢，它所有全部都在一层里头，就是我现在有一个 calculator，那这个 calculator 它可以 take 不同的 object variable，那它会 perform 不一样，那我要你去。我们试着多 create 几个 class 出来，其中把 calculator 呢从 class 嘛把它变成 interface。我们现在要看看就是 abstract class 跟 interface 之间的关系。我们现在要 create 一个 abstract class， 这个 abstract class 它会有 children 就是这个 shape 不同的 shape。那我们希望你们 create 一个 interface， 这个 interface 把这个原来的 calculator 变成 interface， 那他们的计算每一个方法都当做一个 class， 那这个 class 呢，它是会 implement 这个 calculator 的，那我们把它串联起来写个程式。回答这个问题。So, 15 minutes. Okay, let's proceed. Okay, tell me how, if you can solve the problems and show me the code. Raise your hand, you will finish this. I don't see anyone does anything, about this problem. You should discuss within your group. I don't see you do that. So raise your hand, you finish that. No one. Okay, Jack, how can you solve it? It's already? You know how to do it? Okay, use microphone and tell me that. You have already code? Alright, then show us. Yeah, show us your code. Yeah.
喂，this 就是这边先弄个副类别叫 calculator，然后用圆去继承它，然后这边设一个它的那个半径，就是它的长度，然后这边是那个圆它自己里面的，就是它呼叫这个之后再叫它这个里面的方法，然后这边可以用半径成排，就可以算它的 area， 然后这个 square 也是一样。
Good for Jack, but this is not what I wanted to see. I wanted to see it is maintainable, right? And whenever we add new class or method, that will not change the main code, all right? I want to make it more flexible. So I said that don't just, use this street inheritance. So calculator, I said that. So Jack, think about it. Change calculator as an interface, not a class. And we need to add another abstract class. So today we talk about relationship between abstract class and interface, right? So our abstract class, so you need to create an abstract class. So the abstract class, you can name it as a shape, all right? And the shape, we need to use the calculator, to do something. A calculator as an interface. So think about it. It puts interface as a variable inside the shape, all right? And the interface can calculate area. But whenever it's a circle, a calculate circle become a class. So if you have 3 different kinds of shape, right, then you have 3 different kinds of calculation that become class. You might have the 4 type of the length and the 4 type, the 4th type, probably they can use one of the 3 or the 4th one. Right. So I want you to practice lecture class implement the interface, but we take the interface as a variable to do the thing as a polymorphic. It is not that simple, but not just sit by yourself and does nothing, right? You need to think how to solve the problem, right? Whenever I give you the problems, well, discuss it in your group. Okay. So keep thinking about how to do it. Next, we're going to discuss use case. Use case. Today we're going to describe use case. A use case is a function, right? So use case is a function. Last week we talked about DFD, and then we have process. A process is a function, right? If there is diagram 0, then the function name could be, broader or general, right? So we are going to decompose it, go to lower level of the processes, right? So if your process name, process transaction, for example, is very broad, then we're going to diagram 1. To decompose it, right? Or what it means about process transaction like that. So go to more concrete. The same, as our use case diagram. So the diagram 0, if we have 5 processes, it means that we have 5, at least 5 functions. So we are going to have 5 use cases. 5 use cases. A use case, you put a name in overshade, overshade. So within the boundary, right? So you put the names of the system, right? So you have the system name and you have function name. If you have 5 functions, then you have 5 use cases with a boundary and a system name, all right? Then, of course, the system is going to be used by outsider, right? So by outsider, the outsider will be actor. We call it actor, right? Like external entity, right? It's our DFD, right? This context diagram, you can see external entity. So external entity will be actors, the same. Right? So our actor is going to use the function, not all the function, probably some of the function, right? Actor usually it could be person, right? If there's a person, we put it on the left-hand side. Customer, right? Customer is a role, right? Maintainer is a role, play role, right? So maintainer, supervisor, probably this role, right? If that is person, you put it on the left hand side, right? But actor, the same as external entity. It could be an organization. It could be system. It could be transaction. Right? Everything. Whatever they wanted to ask for information, they become actors. Actor also could be hardware, right? If the hardware, they can send signal, like sensor, right? Send signal, then become an actor. So actor can be valid form, right? So for each function should initiate it from actor, right? Actor needs something, right? So the use case start from request, right, by actors. And then what do we respond at? So our system or the function should respond and then wait for actor to do next, right? So until it's end. The end means that, well, our actor got what they need to have, right? So the function finish, right? But that's basically for each use case, you need to have actor, interact with the function. Okay. For the function, they may have relationship or may not. Right. Usually we have 3 types of relationship. The first type is we just talk about inheritance, generalization, specialization, right? Parents is a generalization. The children is a specialization, right? So it's the use case, right? So the use case may have a broad parent, right? So a broad parent, like I said, the process, transaction. They might have concrete transaction. So they have this kind of relationship, generalization, specialization, right? The second, a use case may depend on, or what to say, may, use other use case. So a function, this function use another function every time. Use that, so we got to include it, right? Or sometimes we need it, not always, right? So we extend it. So you are going to see includes, extends. If the dash line, right, towards the targets. So I am the base one. Every time process the function, I am function, right? I need to execute another function, then I should include it. So I am the base. On the other hand, sometimes then the arrowhead from me, right? Sometimes I wanted to use it, so the different direction. So let's see. So the number of the circle shape, that means the number of functions. So you can see that's purchase tickets, all right. Usually you will probably you'll see purchase tickets right within the oval shape, all right, purchase tickets. But because it's this case tour, it shows that like that. So we have purchase tickets. We have all the other use cases, all right. Usually the number you are not going to have many use cases, all right. Usually the seven to 10 probably, all right. And you're going to see now there's only two relationship, right, between the use cases. You can see includes, extends, but we also have another one, right? We said a generalization. So include means this function, this use case, right? Purchase tickets. Every time purchase tickets need to execute, check credits is also a function, right? So you can see the dash line, right? And then the arrow heads towards the targets, check credits. On the other hand, here, right, we have extend. So whenever we wanted to change the reservations, no. Sometimes we need to check credits, sometimes, you know. So you're going to see the arrowhead, you know, there'll be difference, right? And customer is a person, right? So we use this human figure. Usually we are going to put it on the left-hand side, right? If that is a human, right, it's a role, they will put it on the left-hand side. And like this is a credit system. The credit system, because it's not human, so we're going to change that by using a rectangle, right? Like class rectangle, right? Usually we'll put it on the right-hand side. So if it's a human, I'll put it on left. If it's not human, a human, put it on right-hand side. All right. All these actors are not part of our system, right? Only the function part of our system. So that is use case diagram, right? To draw use case diagram, they show us how many functions. So now we are going to analyze it, right? So how many functions? Also, we wanted to describe each function. We take the most important ones or higher priority, you know, to write the description. And we might put it as the first version, right? We use phase development methodology, you know, to do that. So you need to know what functions that is crucial to our system and what others might not. All right, you got to know the importance of that. So here, that would be the use case, right? The overview of use case. So use case and the relationship between DFD and use case diagram. You should know that. And which parts external, which part is internal. Inside or belong to our system, right? Similar to the DFD, right? Okay, let's take this, for example. So I just talk about the use case diagram, all right, use case diagram. And we choose important one to write the description. Okay. For the file I gave you, about the use case description, this is just one, right? One use case, purchase tickets, not all, because we think it is important, right? So we call this primary flow or events. Everything that happened as events, right? Primary flow or events. Primary flow events. Okay. A use case description will have primary flow or events and also alternate flow events. Alternates and alternates, right? Under alternates and also the alternates. Also we may have subflow. We have a primary flow or normal. You probably see that's a normal flow or events. Right? That is the most important part of the description because we wanted to know actor and our system. Okay. But not just this, right? We have normal flow events or primary flow events. We have subflow. We have alternates. And we also have exception. Almost every function should have exception. Exception means that we cannot do it. We cannot deal with it because usually it happens unexpectedly. I think time. But we know somehow it might happen. So we know this, right? It might happen. There's something wrong for the connection that's right. So almost every function needs to have an exception. It is not the same as alternates, right? To write a use case, of course, we give it a name, use case name, right? Like this. That is the purchase tickets. So purchase tickets, of course, we wanted to describe what purchase tickets is. So briefly describe it, right? Describe that, and so, of course, we have a number, right? So use case, you want use case, like our DFD gives a number, right? Or you have an index, not just a number. And the importance level, right? So if there's a high, then we should write the description earlier, right? If it's not that important, probably we'll put it later, right? Importance level. You have an ID number. You have an importance level. Briefly describe it, right? A brief description. You have the name. Then who is going to use it? So you have the actor, right? So you got to put actor is going to use it and the relationship between use cases. So this use case may have generalization, may include or extend other use cases, right? So you should address this part. And who care this? You have stakeholder, right? Who care this? So a use case. For example, here we have a use case name. So if you have 5 functions, then you have 5 functions name, right? The use case name is bottle box, right? Give it an ID, right? And how important is high or medium or low, right? Importance level. And your primary actor. Here, the use case is bottle box, right? And primary actor and bottler wanted to bottle book, so it's going to have an actor, right? Bottler. Here, use case type is a detail and essential. We have 4 types of use case, right? It could be overview, right? Overview or detail. If it's an overview, just general, general. So this general description, like process transaction is very general, right? So it's overview, but still can provide some information of the system we're going to design. This overview was detail. If it's detail, then it's more concrete, right? If we have three use cases, it's overview. The details, the more, right? More concrete. We may write as essential, right? So essential, we write enough communication to help our clients or for the programmer to understand roughly about the system, right? So for example, this overview, we have 3 use cases. Then so we'll write the descriptions enough to provide what the system would do, right? If we go to real, then we write very specific step, right? To write the step is quite concrete. It's almost go to, because it's real, so we say even though the function is not that concrete, but we still can write the step, right? So if that is overview and real. From the name, we know it's a very general, right? And it's going to have a lot of sub-flow. And later, you think that's, well, the sub-flow, we might take it as another use cases, right? So they become detail and real. So if it is detail and real, it's go to very concrete step, like DFD, go to functional primitive, right? We can write code. So 4 types, so it's going to see overview and detail, right? So essential and real. So you got to decide which type, right? There will be 4 types, right? Combination. So it could be overview, real, overview, essential, detail, essential, detail, real, right? As I just said, that since a higher level, right, we may decompose it to a detailed use cases. So like purchase tickets, we skip all this part, right? We only focus on normal flow events or primary flow events, right? And here it says it's detail essential, right? It says detail. It says Butterbug. It's quite concrete use case, right? Detail. It says essential. Not go to very detailed step. It says details essential, right? And you can see stakeholders who care, right? And the actor. Brief description. Describe Butterbugs, right? Briefly. Describe it briefly. Who's going to trigger that? And relationship, right? See association. So the borrower is an actor, is going to do something, right? To request, wanted to check a book, right? Also, you see personnel office, registrar's office, that's organization, right? We need information, students or faculty staff, right? We need to know that it's the borrower valid, right? Valid users. So here you can see the relationship. Normal flow events, right? Normal flow events, that depends on what type of ads. Then they describe it step by step. All right, 1, 2, 3, 4, 5. And here we have sub-flow, right? Sub-flow. So usually sub-flow, so if we might go to sub, all right? And alternates. This part, I want you, to keep in mind that this is not correct here. because alternates is different from exception, right? Alternates, so you have alternates, right? Exception is every function need to have exception that we cannot control it, but somehow it may happen. When that happens, you may send message to customer to say that's, well, the connection, it's interrupted, or there's something wrong with that. Well, we'll fix it out of service for now, that's. This is use case description here, and it's going to see, which, okay, so we skip some items, all right, and go to normal flow events. So here in purchase tickets, we can see the function to start from customer, right, actor, and the end. So we can see end user confirm the message and then go to what. So it starts and ends, right? It's direct relationship with our actor, right? It's a primary actor. So what do we expect actor do, right? So we expect customer will select option to view flight information. The programmer see that, no, that's our system should provide, right? So remember last time when we talk about extreme programming, right? It's user story. User story, the description will be different, very easy. But here, user story, the statements from user, and here, all the statements from programmer, analyst, right? So we use different way to describe it. It started, and what about the system respond, all right? So you can use a different way whenever you can clearly express the communication, the dialogue between user, right? Between actor and our system, fine. So now you can do this like this, or like a previous one, all right? And then the system prompt for departure, destinations, and the date, right? So the place and date. And what about next? User is going to do something, and the system, and now you're going to see alternates, right? So alternates, with alternates, there are no available flights, right? No available flights. Sometimes you wanted to check that some date, the date, and there's no available flights. Probably not open yet, right? The flight's not decided yet, the schedule not whatever, right? If here, it is a normal or primary flow, let's go, go on first and go smoothly, successfully, right? But here, if we do have, then the system will display, okay, available, available flights, right? It says including the fare, right, the price you want to pay. Or alternate, no, we don't have ads, okay, and don't address everything here. So let's go to alternates. So alternate flow, right? When it's an alternate flow, it's A1, then so what about that? Here, the system will respond. We don't have it yet, right? And user understand that we go to step 2, then user is going to select again, right? To choose again. So here, that's how they communicates, right? And you also can see that alternates, under alternates, we still have alternates. So alternates and alternates. This alternates, and then A2.1, it's not alternates, right? And go, if there's E, it's exception, right? So they are different. Alternates and exception are different. Credit system not accessible, right? It may happen. So what can we deal with that? The designer need to, provide some message that this credit system not accessible. The system got to display the message to notify customer what happens, right? And then go to where we were, right? So go to where we were. So basically, that's about use case description, the relationship, right? And the items of a use case, right? So that'll be the function, okay? Aaron? Okay. So we just talked about use case description, use case diagram, all right? So tell me that what would be actor? What is actor? What would be actor? Cherry. You should know that. Cherry, what would be actor? What would be regarded as actor? Actor. Okay. What is actor? Please don't every time I ask you to use microphone, all right?
User or their other interacting system.
User or other interacting, what else? User, system, what else? Is actor included in the system? Is it inside or outside of a system? Actor.
Outside.
Outside. And
Oh.
what about when we refer to DFD? Actor would be the DFD. Similar to Ben. Answer. Actor. It could be humans. It could be system, and could be
Database.
database. What database is included in our system or outside?
Outside.
Okay. And what else?
I don't know.
Okay. And what about the actor is similar to what is the DFD? What is the DFD?
I don't know.
Who wanted to answer this? Get up.
I think the actor is similar to the entity of the DFD.
Okay. It's an entity, right? External entity. And so we just said that it could be database that's outside the organization. Organization or it's a system with humans, right?
Yeah,
Actor.
yeah.
And what else you can think of? What else you can think of?
I think it's hardware like some monitor.
The hardware, right? So hardware, but hardware with software because it can provide any techno, right? Okay. Yeah, and yeah, that's right. And what else is missing? That could be an actor. Eva, what else could be the actor?
Stakeholder.
Stakeholder is human or organization, right? So the same stakeholder. What else you can think of that become an actor? Raise your hand if you understand that. But that thing, actor means we cannot control it, all right? So, actor, what else you can think of? There's also an actor, right? We call this time. Time, right? Because the time will trigger our system, right? Whenever we wanted to maintain the system, right? So, for example, we set at midnight,